Okay, so this video is to prepare you for the common task for quarter one. On this common task, you're going to be asked to graph this function. This is a rational function. And you're going to be asked several questions about the function and its graph. For example, where is the vertical asymptote? Where is the horizontal asymptote? Where is the hole? What is the limit as you approach certain values? What are the intercepts? What's the domain and the range? So there's about 15 questions to answer after graphing the function. So let's first simplify and graph this function. So the first thing you should do is see if this thing factors. So you've got x, you need two numbers that multiply make 5, 1 times 5, that would be positive 5 minus 1, that gives you 4, x, 20 would be 4 times 5, and everything's positive. And then of course you can reduce this right here, and now your new function is x minus 1 over x plus 4. So this is an equivalent function in reduced form. And you should make note of the fact that you could not plug in -4 here or -5 here in the original function. And in the new function, you still can't plug in -4. So this is an asymptote because you can't plug it in no matter what. And this is a hole. Okay, and those questions are listed on your common task below. So I'm just going to make a little graph here so we can answer all these questions by looking at the graph. So we know there's an asymptote at -4, 1, 2, 3, 4. Okay, so we'll just make a table to plug in some values so we can get an idea of where this graph is moving in which direction. So we'll plug in, let's say -5 to see what's going on after the asymptote. So -5 minus 1 is -6 over -5 plus 4 is -1. So -6 over -1 is 6. So at -5, we're up here somewhere. Okay. We could plug in -6. -6 minus 1 is -7. -6 plus 4 is -2. So it's 7 over 2, which is 3.5. So it's decreasing, and you'll see if you continue to plug in values that it's going like this, approaching the asymptote. If you plug in a really low number, maybe we do -10 just to see, you'll get -11 over -6 or 11/6, which is 1 point something. And you'll see that you're actually approaching 1 over here. We'll talk about that in a second. That's a horizontal asymptote. If we plug in numbers on the other side of the asymptote here, like -3. -3 minus 1 is -4. -3 plus 4 is 1. So -4 over 1 is -4. So we're at -3, -4, we're down here. And you'll see that it's starting to go like this. We could plug in -2 or even -1. Or 0 for that matter. So we could plug in 0. 0 minus 1 is -1 over 4. So -1/4. So you're here. At some point you're crossing this, and then we'll talk about that because we're looking for the x-intercept. And you end up approaching 1 on the other side. You can plug in a value like 10. 10 minus 1 is 9 over 14. So you're approaching 1. You could plug in 100 just to see. You'd get 99 over 104. You're getting closer and closer to 100 to 1, but you're never reaching it. So that's a horizontal asymptote, which is 1 in this case. And we know this. We'll learn about this a little bit later on. You should have learned about it in pre-cal, but we'll remind you, when they have the same exponential value, the numerator and the denominator, you just look at the coefficients, which in this case is 1 divided by 1. So the horizontal asymptote is at 1. Okay. So you're going to be asked that question. Let's just answer it now. Horizontal asymptote is at y equals 1, this line this way. The vertical asymptote, which is this line I drew here, this dotted line, is at x equals -3. So that's 2 of your 15 questions. So here's your graph, just a little sketch. And then you're asked about a hole. Is there a hole in the graph? And we remember that we couldn't plug in -5, but now we can. So if we plug in -5, which is here, right? Well, we did that, -5, 6. So at -5, 6, this is a hole in the graph because I couldn't plug -5 into the original, but now I can. So the hole is at -5, x equals -5. Or we could answer it as -5 comma 6 if we want to say exactly where it is. Okay, so that's another question you're asked. We're looking at the limit. Oh, I guess we'll do, let's do, we did horizontal, vertical. Another question is it continuous? Continuous, and the answer is no, because there's a break in the graph. Anytime there's an asymptote, the answer would be no, it's not continuous. So that's another question. Let's look at the intercepts. We want to know where the x-intercept is and the y-intercept. Remember, in order to have a y-intercept, x would have to be 0. So we go back to the original function. If I, or even here, if I plug in 0, which I think I did on my list anyway, we get -1/4. 1/4. So that's right here in the graph. That's my x-intercept. That's another question. The y-intercept is when, oh, wait a minute, that was, yeah, well, this was my y-intercept, sorry. That was my y-intercept is when x is 0. The y-intercept is when x is 0. So, I'm sorry, this is my x-intercept. X-intercept is when y is 0. So we set y equal to 0. So in this case, this equals y. We'll say equals 0. And the only way that can happen is if, where is that? Okay. Is if the numerator equals 0. We talked about this on the test. The only way a fraction can equal 0 is if the numerator equals 0. And the only way that's going to happen is if x equals 1. So at 1, 0, which is right here, it crosses the axes. So now you have your y-intercept and your x-intercept just by plugging in zeros. And then we just look at a series of limits. The limit, can we still see this? The limit as x approaches -3, and we plug that in already. So some of these answers will already be here in our previous work. And it's continuous at -3, right? And we get exactly -4. So that's the answer to that. We have the limit, oops, can't see that. The limit as x approaches -4, okay, and that's the asymptote, right, at -4. So the limit doesn't exist because you're going to -infinity here and +infinity here, so does not exist. We have the limit as x approaches -4 from the right. So if we were approaching the asymptote from the right, we'd be going to infinity. So that's the answer to that one. The correct answer to that is the limit doesn't exist because you're not approaching a number. But in this case, because we're coming from the right, we can say that it's going to infinity. And it's understood that it doesn't exist. It's just going to infinity. Another question is, what is the limit? There's another color. The limit as x approaches infinity. This is talking about the horizontal asymptote. So as x, and this is coming up in another section soon, as x approaches infinity, what is y getting closer and closer to? And the answer is 1, which is the horizontal asymptote. So the answer to horizontal asymptote here will be the same answer to this question. What is the limit as x approaches infinity? Which is 1. What is the limit as x approaches -5? Now that's the hole we were talking about. Going back up here. You couldn't plug in -5, but now you can. We have that answer here. So the answer is 6. You're getting closer and closer. You can see that you're getting closer and closer to 6 as you approach 5. So all the answers, once you've drawn the graph, most of your answers are there. So it's pretty straightforward. And then that just leaves us with a couple of final questions. What is the domain of the function and what is the range? And the domain is all your x values. In this case, you can plug in any x value except for -4, okay? So your domain is all real numbers except -4. So, where can I write that? I'm running out of space here. So the domain is all real numbers except -4. And another way to say that is that you can plug in anything from -infinity to -4, together with everything from -4. Actually, you can't plug in -5 in the original function, so that's not part of your domain either. Sorry about that. So you can't plug in -4 and you can't plug in -5 in the original function because there is a hole and you have to represent the hole as part of your domain. So your domain is all these x values up to here and then continuing. So it's -infinity all the way to -5, then -5 to -4, which would be represents in the graph from here up towards -4. You never really get there. Together with -4 to infinity. Sorry, that's a little squeezed in there. Okay, and then the range, it's getting a little messy. The range is up and down, your value is up and down, so this thing goes from -infinity all the way up until you get to 1, then it skips over 1 and goes from 1 all the way up to infinity. So we have -infinity to 1 together with 1 to infinity. And then finally the last question was name 3 intervals where the function is continuous, and that's the same question as the domain because it's continuous from left to right. We're talking about continuity. It's continuous all the way till you hit this hole, and then you continue up, then it's discontinuous here, and then it continues here all the way to infinity. So your domain really is the 3 places where it's continuous: here, here, and here. And I think that's everything. I'm going to give you one to practice, and then we'll go over it together.